This is also on the worksheet Inscribed Shapes, and we're looking at question number 9. Somebody had a question on number 9. Segment AC is a diameter, so that tells me that this segment AC passes right through the center of the circle. Find the measures of all the missing circle arcs and inscribed angles, all of the missing circle arcs and inscribed angles, and label the diagram. Alright, so it's funny, I wrote segment AC is a diameter. Pretty much we've already been told that, so I'm not sure why I actually put that hint in there. Okay, well, let's find all the things we know. I already had covered this on the video, just some ideas of how to do this, but let's go over this together. I'm going to go ahead and erase some of these dots that I put on for the video. In case you're not seeing these, class, you need to be watching your guidance videos for every worksheet, because I'm going through questions and giving you tips and advice just like I would in a normal classroom if I was with you. So, first thing I want to see here is, if I've got a triangle inscribed in a circle, and I know that one of the sides of that triangle goes through the diameter, well, that means, class, that this inscribed angle ABC, it touches at C and at A, and this is a semicircle. I know that arc CDA is a semicircle. That means it's 180 degrees, and we know that this angle B is half of that. It's an inscribed angle. So the measure of angle B is equal to 180 divided by 2. So there's the first thing I know. If this is a diameter, this is a semicircle, which means this is 180 degrees, and that means this is half of that, or divide that by 2. And by the same property, I can also find this angle. Now be careful. Don't assume that these two angles are going to be 90 degrees in every diagram you see, because if this is not a diameter, that process does not work. It will not work. You're going to have to figure out either the angle itself some other way, or figure out what the intercepted arc is, and then divide that by 2. In this case, they end up being 90 degrees. So if this is 90 degrees and this is 23 degrees, then we can find the measure of angle A. It is going to be 180 minus 90 minus 23, and that's going to be 67 degrees. So there is my angle. Some of you assumed that these two triangles are reflections of each other, and that's a big mistake. We cannot assume this is 69 degrees because we don't know if these two triangles are congruent or a reflection of each other. How do we find the measure of angle DCA? Actually, I shouldn't have labeled this measure of angle A. That's deceptive. Let's call this the measure of angle CAB. There's that angle. Now let's find the measure of angle DCA. The measure of angle DCA, well, that's the same process. Triangle sum theorem, 180 minus 90 minus 69, and that's going to be equal to 21 degrees. So now we've got all the angles of our triangle. It should be no problem at all to find all the measures of our arcs. If DCA is 21, then arc DA, let's do this in a different color, then the measure of arc, I'll try to write this, you can read this, the measure of arc DA is equal to 21 times 2. Inscribed angle times 2 give us the intercepted arc. So that's 42 degrees. So far, so good. By the same property, if this inscribed angle is 23, this is 23 times 2, which is 46 degrees. 67, angle CAB cuts out this part of your circle, or this intercepted arc. 67 times 2 is 134. And then 69 degrees, here's my angle, inscribed angle DAC. Multiply that times 2, and that is 1 38. By the same rules, class, I'm just multiplying these by 2. And then it says check your work to verify you did it right. This is a good idea on a test. If I did my work right, then these arcs around this whole circle must add up to 360 degrees. So 138 plus 134 plus 42 plus 46. Let's check that out. 12, 13, 14, 20, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 1, 2, 3. So 360 degrees, boom, we know we've got this right because those three arc measures add up to 360 degrees. So there is your support on question number 9. Thank you for this question and keep them coming, class.